got them? Okay, so we'll get started on this. Pretty easy stuff today. It's gonna be
Chip Kelly.
thank you. Chip Kelly it is. Okay. We're going to be discussing right here ratios and rates. Anybody in here drive to school today? Did anybody drive to school from the country at all today? Savannah, I'm going to pick on you today. Is that right? Savannah, first of all, what kind of vehicle did you drive?
1989 Malibu.
Chevy? All right. So you're probably going about a buck 20, buck 30, 130 down the road, passing Fords. Yeah. Hey, when you drove into town today, did you ever look at your speedometer? You never looked at it? Hey, we're recording this right now, you know. Okay. You might want to make sure that down the road you take a look. Is the speedometer broken? It works. Have you ever looked at the speedometer before?
I think so.
You've never looked at it before?
You know what this speedometer is?
Do you know what it is? It's not the thing with 1, 2, 3, 4, 5. It goes 10.
It's the speed. It's how fast you're going.
Oh, you looked at it today? You did look at it today. Guys, I'm just going to warn you.
How did you get to
I'm going to warn you.
Well,
When,
with your driver's ed.
I know, I know like how fast usually I have to go. I don't know.
when Savannah's out, stay off the sidewalk. Okay? Alright?
Never asked me if you were right again.
You know how fast you were going?
Yeah.
How fast?
I don't even
Like in town or
Well, just like out in the country.
like 60?
60. 60 what? $60? Were you going 60 years? 60 inches? 60 miles? What?
Miles.
She was going 60 miles per hour, right?
Yeah.
Isn't that speed?
60 miles per hour. Guys, in this section,
Yeah, I know.
if I asked Savannah, say, how fast are you
There's
driving?
no
She says 60. I was like, oh, you were driving 60 corn nuts today. Is it important to put units with values or
Yes.
not?
Yes.
Okay. When we start, and that's an excellent example, when we start talking about rates and ratios in here, that would be an example of a rate because we're comparing miles to hours. That means that she can go 60 miles for every hour if she would maintain that speed. Here's one for you. Other day I went to the grocery store, okay, went in there and I picked up some sirloin, and the sirloin that's there says $7.99. So I can buy as much sirloin as I want for $7.99, right? No? It's per what? So I gotta pay a certain amount of dollars for every single pound. So I'm comparing the number of dollars to the number of pounds that I buy. All right, my apples that I buy, my Honeycrisp apples, $2.29. I can get as many apples as I want for $2.29, right? Really? You mean I gotta pay by the pound? Okay, here's one I know I'll get away with. I went to the gas station the other day. It said $1.91. I can fill my truck up completely for $1.91, right?
Got a lot of fuel saver.
I do. I can fill my truck up for $1.91, right? Can't. If I bought how many gallons, I could.
$17.
1 gallon, but is that gonna work? No, because it's per what? Yeah, we're comparing cost to gallons, right? So we're gonna be comparing units. So what I'm gonna get at in this section, are units gonna be important or not so important?
Yeah.
Units will be important, right? Units will be very important to us today. Okay, so let's check out our goal here today, guys. Goal-wise, we want to write what we call ratios in, what's the word?
Simplest form.
4/8. What's its simplest form?
4/8.
4/8 simplifies to a half, right? 4/8 would simplify to a half, wouldn't it?
Yes.
Okay, so we want to make sure we're putting stuff in simplest form. We're going to be looking at solving problems involving ratios. And we're going to talk about this idea of what a unit rate is. Everything that I talked about to you today was a unit rate. She drove 60 miles per hour. That per hour is per how many hours? Per 1 hour, right? I go into the grocery store, buy apples at $2.29 per 1 pound, right? The gas station, I fill up for $1.91 per 1 gallon, right? So that's kind of like a unit rate right there. So we've kind of touched on these already right here, vocab terms, but a ratio. Ratio right here. Let's just kind of talk about this. Ratio right here says it's a quotient. Quotient being what operation here, kiddos? A quotient is what operation in math? Addition, subtraction.
Division.
It's division. So think division. It's going to be division between two numbers or quantities. As an example, we talk about maybe the ratio of boys to girls in here. Boys, raise your hand. How many are there? 2, 4, 6, 7, 8, 9. Good. 10. Austin got his hand up just in time. All right. All right. How many girls are there again? 2, 4, 6, 8. Ooh, we appreciate. There's 8 to here. 2, 4, 6, 8, 10, 12, 13. There's 15 girls in here. Boys, good job. 10 boys to 15 girls. Good job, boys. All right, so I would say the ratio of boys to girls in here is 10 to what? 15. We're comparing boys to girls, or person to person, right? Okay, percent. Y'all know what a percent is, right?
Yes.
Percent's going to be a ratio in which the second number is always what? 100. Why percent? How many cents in a dollar? 100, right? How many years in a century? 100.
12.
Okay? This idea of cent, 100. Okay? A rate. Rate here is a ratio of two different types of measurements. A rate would be the example like 60 miles per hour. We're comparing two different units. We're comparing miles to hours. That would be a rate. And then a unit rate is a rate for 1 unit of given quantity. Okay, like $2.29 per 1 pound. Okay? So, I know we read through that quickly, but if you hear me use those words and you forget what one of those words means, where can you refer to it at?
Vocabulary box.
Right there. Okay. Guys, get this down here quickly. Ways of representing ratios. What did we say the ratio of boys to girls was in here?
10 to 15.
Okay, I'm going to write down the ratio of boys to girls is 10 to 15, right? Okay, now, 10 to 15, we said ratios can be written as a quotient or division of two numbers, okay? Division is really a favorite F word. Fraction. Right? Right? I can write this as 10 over 15. Okay? But keep in mind, up top I told you I want to express all fractions in what form? Simplest form. So what's 10 over 15 going to reduce to? What would go into 10 and into 15? 5 will go into both, right? So this is going to reduce to 2 to 3, isn't it? Okay. What it means here, gang, is this. For every 2 boys in the class, there are 3 girls. For every 2 boys, there are 3 girls. Okay? So keep that in mind. Now I'm going to show you how to write these ratios here in a second, but I want you to also understand this. When you start looking at problems, the order in which they want you to compare stuff in the problem is very important. If I would switch this around and say, you know what, let's not do boys to girls, let's do girls to boys. And then instead of being 10 over 15, you would have been
15 over 10.
You understand then that the order matters, right? What's listed first is going to go up, and what's listed second should go into the denominator, right? Okay. Now, you're going to see ratios written just like this. 2/3 is simplest form. You might also see it written like this. They might write it as a 2, put a colon, and 3. If you see that right there, that's the same as a fraction, 2/3. That's one other way of writing a ratio. There's a third way to write it. You're just going to write the word 2 in between your values. So this could also be written as 2 to
15.
2 to 3. Okay? These three things are exactly the same. Alright? So you understand that if you see a ratio written in any one of those forms, they're all interchangeable, right? Okay, questions to this point? Okay, let's look at a real life example here and how this might work. I'm on example 1 right now, and in example 1 it says the Department of Fish and Game plans to stock a pond with 200 bass and 150 trout. Mike Trout. Okay. What's number 1 asking us to do?
Find the ratio.
Find the ratio of what to what?
Trout to bass.
Trout to bass in.
Simplest form.
Okay. How many trout do you have here, kiddos?
150.
How many bass you got?
200.
What number is going to go first?
50.
Which is what value?
Trout.
So this is going to be the same as 150 over 200. Okay. Well, I have to reduce this. Wouldn't 50 go into both of those?
Yep.
How many times will 50 go into 150?
55.
How many times does 50 go into the top here?
3.
3, right? How many times in 200? Okay. Well, it says what's the ratio of trout to bass in simplest form? What this means is for every 3 trout that are in the pond,
4 bass.
there are
4 bass.
4 bass. Okay? I could say a joke, but I'm recording it, so I'm not going to say it.
Pause.
Probably means there's more bass turds in the pond than there are trout turds.
Oh my.
That was a good one. All right, never mind. You guys. All right, I want to talk about number 2. This is a good one.
Star.
Star it. What am I looking for in number 2?
Nearest tenth and the percentage of stock fish.
To the nearest tenth, what percentage of the stock fish are bass? Okay, here's the deal. Guys, on your test, how many points were on your test today when you looked at it? Anybody catch that? 28, right?
Yeah.
And to turn that into a percent in the grade, I took what you got right divided by the total number, right?
Yeah.
Okay, so basically a percent basically is take your score or the amount you want or had divided by the total, and then times this by what?
100.
Okay, so here's the deal. We have this pond that's full of fish, right?
Yeah.
Right?
Yep.
Okay, this pond is full of fish. We've got some bass in there and we've got some trout in there. Okay? The question says to the nearest tenth, what percent are bass? Well, how many are even bass to begin with?
200.
Okay, so I want the number of bass out of the total number of fish in here, and then we're going to take that answer times 100 to turn it to a percent. How many bass were there again? How many?
200.
200. Got a question here. How many total fish are in the pond?
Oh, there. 150.
350. You've got 200 bass, 150 trout, right? Total together, how many total fish in there? 350, right? So we're going to go 200, divide that by 350. Since I want a percent, what do I have to multiply by in the end?
100.
Okay, so let me pull my calculator up. Let's see what we get here. Let's see, where is that? There it is. All right, so I'm going to go 200 divided by what?
350
Times 100.
or you can
And it looks like to me I get 57 point to the nearest tenth. Is that to stay a 1 or go to a 2? 57.1%. So what percent of the fish in there are bass?
57.
57. Would you guys agree that there's more bass than there are trout?
Yes.
So do you agree that that should have been higher than 50%?
Yep.
Okay, so it is. And it is, right? So we get 57.1%. So percents. Basically take what you're after over the total, times it by what value?
100.
100. Okay? Questions there at all? Everybody have your notes down? Okay. Savannah, you got her, kiddo?
Whoa.
Good. Anybody else need more time with that? All right, let's take a look at page 2 here quickly then. Is that what you guys have right there? Does it say number 3?
Yep.
Okay. It says in number 3, next year the department plans to add how many trout and bass? 700 in the same ratio. It says how many of each fish will be trout and how many will be bass. Okay, well here's what we're going to talk about doing. Okay? A couple different ways I could do this. Looks like we're adding how many total fish again? 700 of them, right? We're going to add 700 of them. Okay? Well, a couple ways I could do this. We had just said on the last page that 57.1% of them were going to be what? Okay, 57.1% of them were going to be bass, right? Okay, so if I'm turning something into a percent, you would do your division and then times by 100. But to go backwards right here, what I could do is I could take this times your percent and then divide by what? Okay, so let's check this out. Guys, what's 57.1% look like as a decimal?
57.
You move it back to the left how many places? As a decimal, this is 0.571. So to find 57.1% of the bass, or 57.1% of what value here?
700.
I could take 0.571, that's how you write that percent as a decimal, right? Times what value? Well, how many total fish are you throwing in there again? How many total fish are you throwing in there again?
700.
Okay, so let's do that quickly. Let's take 57.1% of 700. You could simply go 0.571 times 700. Oh, it looks like 399.7. We're talking about fish. Let's talk about whole fish, because part of a fish just, I don't think it's going to be alive. Okay?
It'd be 400.
Probably 400, right? Right? So how many of those fish are going to be bass when we throw them in there?
200.
Oh,
400.
400. Okay. So this here is equal to 400. So we're going to be putting 400 bass in. Well, if that's true, kiddos, then how many trout are you going to be putting in with the 700?
300.
Yeah, 700 are going in, 400 are bass, so that means then you have to have 300 that are trout. Oh my goodness. Would you guys agree that 300 over 400 reduces to 3 over 4?
Yeah.
Agree with that? Reduces to 3 over 4, right? That ratio would reduce to 3 over 4? Or 4 over 3, whichever way you're going. Holy smokes, I think I've got to go look at something here. No way!
Oh.
Same ratio, right? That's what was already in there? No way. We want to keep ratios the same, don't we? Okay. You understand how this idea of percentage then ties in here? If I can turn something into a percent, turn your percent to a decimal and times by the total, that'll get you what you're looking for. Alright, so what I would ask you guys here, give this a shot on your own. These 3 problems on your own, right here. See what you come up with. And man, if you get stuck, talk with a neighbor around you. See if you agree, disagree. If you disagree, talk about why you disagree. But right here, I want you to try these right in here, in the yellow, and see if you can get an answer. Okay. First one, you're writing a ratio. Second one, you're figuring out a percent. Third one, you're figuring out another ratio. Okay. We're missing Christian today then, right? Is that the only one? Oh, you got Christian.
Oh my, that broke.
Yeah. Did I steal yours?
No, that was yours.
was that?
It was that bar from the chair keeps falling off.
Isn't that bar, didn't that make its way to the garbage already? What
No.
bar?
We just stick it back in the one hole.
Just throw it away. Chairs were built by the Ford company.
Yeah, I weld it for you.
You don't, you can just throw it away.
Have you seen the chair?
I like putting it back in.
Okay guys, the first one right here says a rectangle is 12 inches what?
Wide.
And 18 inches long. Write the ratio of what to what? What's the wording up here? How's the order go?
Length to width.
Length to, whoops, didn't want to do that. This is what I want to do. Length to what?
Width.
Okay, so length to width. Guys, what is the length again? 18. So we're going to go 18 to what? Length is 18, width is 12. But I want that in what form all the time? I got to have simplest form, right? 18 over 12, what's that simplify to? 3 to 2. How many had 3 to 2 there? Again, I don't care how you write it. I don't care if you write it as a fraction. I don't care if you put the colon between it. I don't care if you put the word 2 in there. All right? But I'm going to write this as room-wise, 3 to 2. It means for every 3 units of length, you have 2 units of width. How many had 3 to 2 there? I'm just curious. Anybody have 2 to 3? Okay, you understand why it's 3 to 2 and not 2 to 3? The order of what they're asking matters. What's listed first goes first. What's listed second goes second. Okay, so don't get caught on that. Second one says sales tax on a $90 dress was $4.50. What percent is this? How much? How'd you get 5%?
I took 450 divided by 90 times 100.
Yeah, 450 divided by 90. And then you got times it by 100 since it's for a percent. How many got 5% for that?
I did.
Yeah. Take your tax, 450, divide it by the cost of the dress. You got 0.05, right, when you did that? And then you got to move that decimal 2 to the right, or times 100. You would have 5%. I'd take 5% on sales tax, wouldn't you guys? What are we in Iowa, especially Blackhawk? Are we 7?
7 point.
That's why I like shopping for clothes in Minnesota. No sales tax on clothes up there, right?
Really?
Yeah.
Well, the Minnesotans got it figured out. He's smart. A gear with 100 teeth drives a smaller gear called a pinion with 20 teeth. What's the gear ratio of the teeth? Well, we're going to go 100 to what? 100 to, it says write a ratio, right? Could that be reduced at all? To what? 5 to 1. Okay? Perfect example right up here on the board. Gear ratios. Big gear, little gear. 6 teeth. Never count. 50. 15, 6. What's the gear ratio in simplest form? 15 and 6. What number would divide evenly into 15 and 6? Not 2. 3 what? How many times up here?
5.
For every 5 teeth on the big gear,
2
2 little teeth here on the little gear, right? Okay? This making sense?
Yeah.
Pretty gosh darn easy, isn't it? Okay. Let's talk unit rates then here quickly. Guys, I'm on example 2. In example 2, it says a 2-quart size of laundry detergent is what? Costs $2.99, right? While the 50-ounce size costs $4.99. Uh-oh. Which is the better buy? I want to talk about this real quickly. Two-quart size of laundry detergent costs what again?
$2.99.
Okay, I'm going to write this down. We have a $2.99 cost for 2 quarts, right? And then for the next one, we have a $4.99 cost for what unit? $4.99 is gonna buy you what? 50 ounces, right? Okay. Hey, quick question right here. We're trying to figure out which one's a better buy. Now, when we go into the store, we always say the better buy would be something that is more expensive or cheaper.
What one?
A better buy would be something that is
Cheaper.
cheaper. Okay. By the way, some stores have started doing that now. I don't know if you've noticed.
Do what?
I think Walmart's most notorious for it.
Do what?
They put in like the unit price, like 6 cents per ounce or something like that. Have you noticed that? They'll say like $5.99 right here, and then off to the side they'll have like 6 cents over here, meaning it's like 6 cents per ounce. Have you seen that before?
Yeah.
Okay. Here's the deal, guys. When we want to start talking about buying stuff in terms of cost like this, we have always got to make sure that we have the same units. Now, in each of those ratios up there, do I have dollars in the top for each one of them?
Yeah.
How about my units for the denominators? Are they the same or are they different? Ooh, they're different, right? We have a problem, don't we? We've got a big problem. We got to make sure that those are the same in the bottom, right? So somebody do this for me. Google up how many ounces are in 1 quart. Google it up. How many ounces in 1 quart? Or if you just know it.
32.
There's 32 ounces in 1 quart.
32.
1 U.S. quart is 32 U.S. fluid ounces.
Say that one more time.
1 U.S. quart is 32 U.S. fluid ounces.
So 1 quart is 32 ounces, huh? All right. How many quarts you got down here?
2.
How many ounces would that be totally then? Well, it would be 2 times what?
32.
Okay, do this for me now. This would be the same as 64 ounces down here, wouldn't it?
Yep.
That'd be the same as 64 ounces, okay? So what I could do now is this. In each of those, am I comparing dollars to ounces now?
Yep.
Okay, divide that out for me, the first one. $2.99 divided by 64. Tell me what you get. I'll put it right up here too. So 2.99 divided by 64. You guys agree that we have 0.046? So that's about 4.6 cents per ounce. Okay, write this value down, 0.046. Okay, now I already know which one's the better buy without even punching this up. Anybody know which one it is? First one or second one?
First.
What would your argument be there?
Second one.
You have 64 ounces.
You're buying more ounces here for less of a price, right? Isn't that the definition of cheaper in most people's book? Get more for less?
Yeah.
Okay? Well, let's just look at this numerically and see what it looks like. $4.99 divided by 50. Ooh, I got 0.099 for this one. Guys, these are considered unit rates. This is about 9.9 cents per ounce. This is about 4.6 cents per ounce. Obviously, which of these two decimals is cheaper or the better buy? First one is. So when it says which is the better buy, am I going to buy the 2 quart size or am I going to buy the 50 ounce size? Which one would you buy? Yeah, okay. So I'm going to write over here the 2 quart option is
We go to,
oh, we do, don't we?
let me know.
Um,
Do we go to advisory?
I have to get you an assignment. If I put it on announcements today, will you promise to look? It won't be due until Tuesday.
Yeah.
Okay, well, I'm sorry about that. I totally lost track of time.
Wait,
Okay,
how are you gonna do it?
I'll put it on announcements, okay? Or my webpage. It'll be on my webpage too.